Alright, I'm going to do some solving by elimination with multiplication involved. These simultaneous equations don't have any pairs that match up nicely, so I can't just add or subtract these equations. I need to actually do something else to them first. So first thing I'm going to do is just label each of these. I'm going to call this equation 1 and I'll call that equation 2. Now I can see that I've got a 4x there and a negative x there. If I can multiply this whole equation by 4, I'll have negative 4x. So if I get that equation 2 and multiply it by 4, I would get minus 4x, 5y times 4 is plus 20y, and 15 times 4 is 60. I'll call that equation 3. Now you can see that if I get equation 1, and if I add that to equation 3, I should get rid of the x's. There'll be 0 x's. 20 plus 3 is 23. And negative 14 plus 60 equals 46. Oops, 23y. So this looks like it's pretty straightforward because I know that 2 lots of 23 is 46. So y must equal 2. Then all I need to do is to substitute y back into one of the equations. So let's put it into, let's put it into 2. So negative x plus 5 times 2 equals 15. Negative x plus 10 equals 15. I'm going to get rid of that 10 by subtracting it on the other side there. Negative x equals 5. So if negative x is equal to 5, then x is equal to negative 5. Okay, that's that one done. So if I want to check this, I just substitute these numbers back into one of these equations. X equals minus 5, y equals 2, so that'll be negative 20 plus 6 equals negative 14, so that works out. Okay, I'm going to do it with this one over here now. This one over here, not as straightforward as the last one. In this one I could just multiply one of them by a number to pair up things. But over this side, not so easy. But I can see I've got a positive 2y and a negative 7y. I can think about, well, what do both of those numbers go into? They both go into 14. So if I can make that into 14 and that into 14, I can add them together to make them 0. So let's label these as 1 and 2. And if I get 1 and I multiply it by 7, and if I get 2 and I multiply it by 2, let's see what I get. So 1 times 7, 7 fours are 28x plus 14y equals negative 23 times 7. It's going to be negative 161, and I'll call that equation 3. 2 times 2, so 5 times 2 is 10x, minus 7 times 2 is minus 14y, and minus 5 times 2 is minus 10. I'll call that equation 4. So I've had to change both of them so that I can get something that I can easily work with. I could have multiplied this one by 5 and that one by 4, and then I could have done some subtraction, but it's always easier, if you can, to add them together to cancel out a negative and a positive. 28x plus 10x is 38x. Minus 14y and positive 14y gives us 0, and that's equal to minus 171. Why did I pick one with big numbers? Anyway, x is then going to be equal to negative 171 over 38. So what I should try and do here is find something that goes into both numbers. Now, that is not easy, because if I look at the number 38, the only things that go into 38 are 2 and 19. Maybe 19 goes into 171. Let's try 19 times 9. Now, the reason I'm trying that is because I know that 9 times 9 ends with a 1. I know that 20 times 9 should be 180, so I think this is going to work. 9 9's 81, 1 9's 9, plus 8 is 17. Gee, got it right, fantastic. So x is going to equal negative 9 over 2. And as I said, you could use a calculator to do that. So now I need to substitute x into, pick one to substitute into. I'll substitute it into, I guess the first one, might as well, into 1. So 4 times negative 9 over 2, and you can work with decimals on this, plus 2y equals negative 23. So 4 times negative 9 over 2 is going to be negative 18. Yes, that's right, take my word for it. Plus 2y equals negative 23. Negative 18, to get rid of that, I need to add it on the other side. Negative 23 plus 18, 2y will equal negative 5. So y will equal negative 5 over 2. Or negative 2.5, depending on how you work it out. Okay, so hopefully that's been helpful. Keeping in mind what I've said, you can use your calculator when you get to tricky fractions. Don't mind that at all.